Okay, let's just checking if everything is actually good, because I have to open a lot of stuff at the same time while working, and I just woke up, so have to bear with me here for a second. So where did we stop last time? That's why you have always a tomorrow category to put all what you want to do in the next day. So okay, so there is the surface implementation and the DTO, which I didn't understand from that video. I mean, I understand that he did it and how he does it, but I'm not sure why we do it in the first place. I think it was in the service. Yeah, it was in the service.
What's up, guys? This is Steady. Welcome to my YouTube channel. We've already actually first. Okay, so let's actually go inside IntelliJ and let's create our very first service. You would think that you're going to create a service class, but really what you want to do is you want to create a Pokemon service interface.
Yeah.
And this interface may seem like an unnecessary step, but this interface is what's going to allow us to take the service and bring it into the controllers in a way that does not depend on the other one, aka dependency injection. So we're creating the service class.
I forgot which design pattern this was called. Probably another subject that I should dive a bit deep into is design patterns, but that's a topic for another day. In Java Spring Boot, how do we make the service layer has an interface and make a service implementation? Making the service layer interface is a common design pattern to substitute loose coupling. By using an interface for the service layer, the application is less tightly coupled to a specific implementation. The service interface defines the contract that a service should implement, while the implementation class provides the actual business logic. This means the rest of your application does not need to know about the service implementation, only about the interface. You can swap out implementation without changing the code that it depends on, but I don't see why is that. Maybe it can be easier for testing, not sure. Decoupling business logic. The service interface abstracts the business logic, meaning other layers do not need to worry about the details of the logic. I mean, you can do that with or just using the service layer without implementations. If your application has multiple ways to perform the same operation, okay, yeah, in that case you will definitely need an interface, but it's a very niche case. Separation of concerns. I think user service in itself is a separation of concern. Give me a scenario where it will be more official to use that design pattern. 10 in the morning, it doesn't miss the best. I have used all my coffee yesterday, so I have to settle with coffee with the tea for today. E-commerce platform with multiple payment gateways. Imagine you're building an e-commerce platform that supports multiple payment methods like credit card, PayPal, Stripe. Each of these payment methods requires different logic, but they all need to follow a similar structure. They need to process payments, handle refunds, and validate transactions. Without using interface and proper abstraction, you would likely end up tightly coupled code, which would be harder to maintain and extend in the future. You start by defining the payment service. Okay, it's called the task service, but I don't think in our case we will be using the task service with anything else. have the payment service interface, and then refund, and then you make a service credit card payment service, and then you have strip payment service. So in order to have multiple implementation of the same class, yes, if you have multiple service that goes under the same category, it would make sense to use that, but I don't think we have to use it in our task per se, because there isn't a way to make multiple tasks. But in the future, if we want to add different ways to handle the task, or I'm not sure, different business logic, yes. Okay, I guess I understand the service and service implementation part, I guess. Let's see what else he has to do about that.
The service interface right now, but once we actually get done with the service class, that interface, like I said, is going to allow us to put it inside of the controllers. And because the repository is an interface too, we will quickly be able to put our repository within our service here in just a second. But first thing that we need to do is we actually need to go in here, and we're going to create our very first
now that we are on the topic, I actually need to check how does interfaces work again, because I forgot. How does interfaces work in Java? So the thing about interfaces, you write the method itself abstracted, not with the main functionality, and the one that implements it has to do it. Yeah, with the override. But the thing is, you can make objects of the interface. Class dog implements animal, and animal is an interface. Interface can have method that has constants. I think that's a bit too deep, but I should probably how the GPA interface works.
actual method in here, and it's going to be a Pokemon DTO, which we are going to have to create. So we go in here, and we're going to put that we pass DT, don't pass DTO. You or actually earn data back, or whenever you are pushing data to your actual API, you don't want to a lot of times make it so that all of these values are in here. There may be cases when you don't want the int ID, or you don't want the primary key. There may be cases when you don't want the name. And basically, all that an ETO is it's a model without all of these values, so that you can either submit data in a secure fashion, or you can return data in a secure fashion, because you may not.
I understood the meaning for the DTO, data transfer object pattern, but I'm not sure how to implement it yet.
So that is why we actually create DTOs, and I'm going to just go in here, and I'm going to call this Pokemon DTO. So we're going to go Pokemon DTO, just like this.
And you create it the same way you create the Pokemon class, but with the specific variables that you need.
And the values that we are going to put within our DTO are not going to be hardly any different from actually they're not going to be different at all, but here you have private content. Since they're exactly the same, and on our Pokemon DTO, we can actually bring it in just like this.
Okay, and passing that instead of the actual class.
So now what we want to do is we want to create what's called an implementation, also known as an implement. So we'll go in here, and within the actual service folder, you could call this whatever you want to. You don't have to do the folder structure like I do. You can do it any way that you want to, but I just called it. I put it within the service file, and then I'm going to go into here, and I'm actually going to create my Pokemon service. Import.
And inside the service, we should not just implement the interface that we created, but also the DTO.
We also need to make sure that we put import on the end as well too, because you need to distinguish them, because if they're that close to each other in a file like that, you don't name them something else, that's only going to lead to disaster. So next thing that we need to do is we need to actually implement this Pokemon service. So what I'm going to do is, since it's an actual service, you need to go up here, you need to add your service so that Spring can register this and knows it's there and can actually bring in all your beans. Then I'm going to go into here and I'm going to go
I'm more interested to see, yeah.
So if you,
so like I thought you use it for the Pokemon DTO. In our case, we will be calling it task DTO. On all caps, I think so. No, just the first. Ah, okay. I already made it, but never bothered to actually put the methods in it. But we should, okay, let's say the tag is important, ID is important, and everything here else is important. Which one should be deleted or not deleted, not be sent? Okay, forget about the DTO implementation for now. Let's just rename the task service, refactor, rename, and we call the task service impl. And we change the name in the other classes also, which is good. Now we go and create our own interface, and we call it task service. So inside the task service, how many methods did we have here? We had this method, what else did we have? We had the create task one, what else? And we add the service annotation, add service. Well, this one will not be a service anymore, I think. Which one will be getting the annotation of the service?
look at the repository this and knows it's there.
The implementation will be the one getting it, but
Do it
the
any way
Pokemon
that you want to,
service
but
itself
I
will
will
not.
create my Pokemon.
Okay. What is the Pokemon service? It's not Pokemon, sorry. Task service itself. Okay, my brain is lagging.
Because you name something else that's only going to really, and after this,
Yes, the implementation has the service, but not the interface. And we say this one extends the actual service task. Not sure why it's showing it in. Yes, we know that we need the implement. We say add override. It's capital, okay, that's why. And we say here add override private task repository, maybe final. I don't think that really matters. One relational problem. What do we have here? Okay, it implements, not extends. So that's the service implementation, and here we should be having also the service implementation. And the argument behind this is because if we have multiple logics towards the same type of method, for example a paying service, there can be multiple payments. In that case you use this, but in our case we just have it so that in the future if you want to add more logic for the same thing, I guess. I mean, our app is very small, so I don't think that will be the issue. So this is for the service and for the service implementation. It wasn't as bad as I thought it would be. That leaves us with the DTO.
Because it's there and can actually bring in. So, first thing, okay, this is when we start talking about AutoWire. So if you look at the repository, like we have this repository over
yeah, here's the DTO.
Here, and we're going to say create Pokemon, and then our Pokemon, we are going to have it so that we service here. And
the thing about DTO is it is exactly the same as the task without the annotations here. So everything here, I guess. Okay, DTO, the T and O should be also in small. I wrote it last time wrongly also. DTO. So these are the main thing, but let's say we want to not return the ID, for example. Okay, let's comment the ID here. Let's comment the setter and getter for the ID. And the constructor itself doesn't have an ID because it's auto-generated anyway.
in just a second.
Now, before I actually check where do we actually use the controller, it's the response that we should be giving. But how do you transfer the information from the repository towards the DTO?
But first thing that we need to do is we actually need to go in here, and we're going to create our very to have to in our Pokemon. First, so if to do is we need.
So wait, the Pokemon service, instead of taking not the Pokemon, sorry. So the service layer takes the information from the repository. Instead of taking it from the repository, it's taking it from the DTO.
Because we don't have it. So first thing that we need to do is we need to create a DTO folder. So if you don't know what a DTO is, whenever you return data back or whenever you...
So it starts from the beginning. I thought we would be only having it between the service and the controller, but no, it's actually also between the repository and the service.
Pushing data to your actual API, you don't want to a lot of times make it so that all of these values are in here. There may be cases when you don't want the int ID, or you don't want the primary key. There may be cases when you don't want the name. And basically, all that a DTO is it's a model without all of these values, so that you can either submit data in a secure fashion, or you can return data in a secure fashion, because you may not want all these values returned. So that is why we actually create DTOs. And I'm going to just go in here, and I'm going to DTO, DO, all, but for here, that's just going to copy. So it's in just here. Now we have our Pokemon DTO, we can actually bring it in just like this. So now what we
Okay.
want to do is we want to create what's called an implementation, also known as, you can do it any way that
We covered the implementation part.
you need. So first thing, okay, this is where we start talking about AutoWire. So if you look at the repository, like we have this repository, is first we have our Pokemon repository. So go in here, we have Pokemon repository. We're gonna go down just like this. And then what you want to do is you want to right click, you want to generate
The constructor.
a lot of, because you know, that methods so that we can send data to the actual.
Okay, let's check so far what he did. Where's the service implementation? Task repository is okay, but we will not be receiving the task here, but rather task DTO, which is of course will give us an error because also the task service itself. Okay, this one is easy to fix, no problem. What is the implementation? The implementation, not the implementation, sorry, the task repository is also giving the task itself.
And the way that we do
Okay, how will be fixing this error? Because the save function will work with the save, not with will work with the task, not with the task DTO.
that, we're going to go in here, we're going to go Pokemon is equal to new Pokemon. That is going to new up, let's get a new Pokemon for us. Then we're going to go in here, and what we're doing is we're going to map it. So you can use actual frameworks like MapStruct and Model Mapper to do this, but I actually think that most places that you work at are not going to.
And it should, okay, this is the service implementation. What's the return type here? Yes, the return type here should also be DTO. Okay, I have my caps on, never mind. Task DTO, create a task, task service implementation. Yeah, also here. So we have DTO here, and also should give back DTO. Now it leaves us with this thing, that the save is taking the tasks, not the task DTO.
So if I were you, I would just get
Create Pokemon, Pokemon name equals new Pokemon, Pokemon equals set name, get name.
used to just mapping stuff yourself, because I've never seen anybody use a mapper in real life or an actual
And set type to DTO, so he manually mapped it, but okay, I need to check on a couple of stuff first. He's doing it in the service implementation, and he wants to create a Pokemon, and by creating he also save it to the repository. How he would do that?
environment, and I think it's easier in the long run. You use mapper, it
Also task DTO dot get title. JPA, where's the repository? Ah. So you make the repository take the DTO instead of the task itself. So here you make it DTO. Actually, let me just get back here. If task, yeah, the task here is not the actual class but the name, and we're saving the task here again, so it should be fine. Here, where is the issue? It says here DTO. Service implementation, get all task, and it will be task DTO. The tasks is the name here, and the new response is okay. Also here we'll be using the DTO. At override here. Wait, why? Getting all the tasks. Public list task DTO. Get all tasks, and then it finds all the tasks. Then here the controller is saying no for some reason. How we made the service implementation with the task, okay, task repository and the controller with the task service implementation, and the DTO is the one that we use instead of, so service implementation we use it instead of service, and task DTO instead of task. So again, public response entity list task DTO. It says one problem. List task DTO, get all tasks. Return java.util. I pressed on something, but I'm not sure what did I do. What is the repository? The repository doesn't have to do anything with this. One relational problem. The requested body would be from type what? DTO. Still not sure how we use the DTO. So instead of using the task with anything that we get, for example, if we got a request, we just make it like as DTO. I'm not sure.
Save you some time, but a lot of times
Pokemon new.
it will
So yes, you get a Pokemon, you take another Pokemon.
it just causes unnecessary complexity. So just fight the bullet in the beginning and just map it yourself. It's a lot
Why just not use the .save function here?
easier thing. So we're gonna go in here. Then we're going to actually access our save, and because
okay, so he's at the service implementation. We will get the DTO, and we will make a new class of okay, I see. So the service implementation here, we will have to do some mapping, because we will be getting a DTO and we will be returning a DTO, but the one that we will be saving will not be a DTO. Okay, so on this part we'll call this task DTO. See here, yeah, I guess sure, also make a DTO here. We'll create what the class, it's task, yes, task, represent view, task, and then how do you set it? Yeah, the task dot set title will be from task DTO dot get title. We will be returning task DTO again with the capital also here. I almost forgot it. So we set the title. What's the information we have at the DTO? We have the title, the description. The is completed will not be necessary at all. It's because the is completed here is always false. What is the task DTO? Just remove this. also remove this part along with this one. So the information we have here is the tag, title, and description. Task dot set title, task DTO dot get title. Also okay, we already did the title. We should be doing the tag. Okay, so we got the title, we got the tag, now the description. Task dot set description, we say task DTO dot set description, not set, actually get. Now we want to go to the repository. Yes, but that would also cause a lot of problem, because now we know for sure it's not task DTO, it's actually task, because we map everything manually. So yes, once find all tasks, how will you map it then back to DTO? The fact that you have to do it manually every time is kind of annoying for this small project, but okay, let's see. So we are getting all the tasks, and all the tasks here are, so we have to make a DTO class. Task DTO, task DTO equals to new task DTO. And we will find all of them, but okay, how would you get the all mapping with the DTO pattern? So the find all here, and task DTO. I know that it will return the wrong thing, but bear with me for a moment. List something seems to be missing here also. Anyway, how do we map objects? Yes, this one should not be. Okay, this one is also wrong. We don't need a single object, we need multiple objects. So we say list. Okay, we need implementations for that. Tasks DTO equals to new, we call it a list. Raw usage of list. I forgot how to even call up on a collection. That's how bad my brain is going today. How to make a list. Yes, I did forget the syntax for this one. List string and equals to a new array list. Yep, that's what I was searching for. The generic type is from task DTO. And then we have here the normal task. How do you map it? Task. There has to be a better way instead of creating multiple values. Now we have to make a for statement that iterates the enhanced for loop. I forgot how to do it also. For task in task repository dot find all Also, another thing, how to make the enhanced loop, actually to be specific, for loop. Type of variable, yes, we have to specify, and then the collection. So here and here it's one type. Yeah, they are from type task, and we will call them T for now. And then we say that the task DTO that we created so for each iteration here we have to make an I also. Int I equals to 0, and I say int I equals to T. Array type is not found. Before I forgot I plus. So the task DTO here is the one that we just created. Is this a spelling mistake? I don't think so. Array type expected java.util list, and then we have task DTO, tasks DTO, and then new array list. Okay, we should also mention here that's also from type task DTO. Nope. Am I missing a thing with writing list? List from type string, here it's from task DTO, we call it a name, we call it task DTO equals to new linked list or array list, doesn't really matter which one, and then dot add. Okay, I forgot everything related to the collection, so shame on me. Dot add, and we say T here. Okay, yeah, we cannot add it because how do you map the entire class? I think we have to do it actually manually here, like this one. So we have the object of the task, now we want the object of DTO, and then to add that object here. Okay, task DTO. Actually, let me just copy this line from here. And then before we add, we will be adding here the task, and before that we should be able to add task dot set title, and then we have task dot set tag and task dot set description. And inside here we will be taking the the t dot get title, the t dot get tag, the t dot get description. some reason something here seems to be wrong. So we created the task from type DTO, and then we added here to the task list that we created. Create a local variable. Yeah, I think it should be inside the... Nope. So we created a task DTO, and then we looped over the repository to get the task, and then map every one of them manually. Not sure why return task DTO is not working. Okay, before it wasn't working, now it's working. Duplicate. I'm not sure why final. Okay, so each time we have to use the DTO, we have to map everything manually. Oof. Okay, let's see how the repository will go. Yeah, possible. Okay, I guess now we finish also the DTO.
Because we actually have our Pokemon repository, we don't have to worry about any of this database stuff. We can just literally say, hey, go ahead, throw this in the database, and we are good to go. Here, now we have our Pokemon DTO. I'm going to go Pokemon response, just like this, and I'm going to say this new Pokemon response is equal to, now we need to new up a new Pokemon DTO, and here in a second we will actually write methods that will make it so that a lot of this stuff is, we just have a method to do all of this, but for right now, let's...
Yeah, I was going to say, if you keep on repeating this stuff, how, before he actually does it, how do we create a method that will automate all of this stuff? You can create a method inside the DTO, and then you call it map. That's my guess. Task DTO, and then you go here, for example, and say there is no return type. No, there is a return type. Public task map task DTO, and it takes which is what normally does is the return type that we're looking for. So we want that task DTO to be returned, and we want to get, so I have the set task here, the task is the, okay, yeah. So we actually wanted task DTO the return, and the input should be task. And then we copy all the things that we just created here in the service implementation, which is this, and also the set description. Except some tweaks here and there, we will actually do it right now. So we don't need an actual task DTO here, or no, actually we do. but we will have conflictions here. We'll call it task DTR, and here will also be DTO, and also this one will be DTO, and also here this one will be DTO. Okay, in a second. Also here will be DTO, and then here will be task. Yes, tasks. And then we return the task DTO. And then when we go to the service implementation, we can just say task dot map task DTO, and we put in the T. Same thing. And here, but there is two type of mapping. There is mapping from where we are returning task DTO, and there is mapping where returning task. This one where the return is task DTO. How is it with this one? So we are receiving a task DTO, and we want to map it to a task. So now inside the task class itself, we will also write another method, but it will be the complete opposite, because here we want it from the to create it from the task. Not sure if that's the same thing that he will do, but I think it's a good solution. Return value of the method is never used. I'm not sure what he means by that, but copy, and then we have it here inside the task, and instead of DTO, just we'll call it map to task. The return will be task, and here will actually be DTO. And here we'll be creating just task, and just task. And here it will be just task also, and here just task, and here just task. Also here just task. In this one it will actually be the DTO, and in this case here also it will be DTO. Also here it will be DTO. So when we actually go to the implementation here, we can just remove all of this. We don't even need a line here. Dot map task, and we put the task DTO. I think it looks good, but I need to test it first. So we have the first post here. Also we need to run this one, and as well we also need to check if there's no logical error, so we'll have to open the PSQL shell also. Select all from task. Select all from, and there is a problem with the T in task, I'm not sure. Okay. Loan book does not exist. And forget about loan book. I hate that I actually downloaded that thing. It keeps on bugging a lot. Okay, thank God, no errors. Nothing here. Actually, to optimize my testing environment here, we'll have this thing like, okay, just disappeared. Should probably have Linux for that thing. Anyway, so we have the post one, we have the post two with adding the description and the tag. Okay, that title is already given. This one is without it. What else did we have inside the DTO that wasn't included? Well, yeah, we have 3 here compared to 1, 2, 3, 4, 5. So the IT is auto generated. We fixed that part, and is completed is by default false. So okay, so we post the first one, it's working. We post the second one, it's working. Now to check if it's saved here, yes, with the correct ID, and both of them are false. Now to get everything, I'm not sure if it will work. Null. Yeah, because we haven't mapped the thing in the controller also. So we did the surface implementation here and here, but let's go to the controller. Where was the method for getting everything? Yes, return task DTO. My brain is absolutely getting fried from this new concept, but that's the post mapping. Everything seems to be working fine here. So the response entity will be a DTO, and we made this one, and we made it to get all tasks. Now to get to the all tasks, the all task returns a DTO after creating a new array list and going through the repository of finding all. And if we go to the repository to the find all, it's from this T, and okay, no, that's the main class, but where's our repository here? We have tasks, so we are getting the task, and it shows these no type error. So yes, we are actually getting the task. So we map DTO, and then we map the task to the DTO, but then we add the task to the task DTO. Actually, for clarity of writing, because I do get confused, task DTO will be referred to as task DTO, and task will be referred to as task instead of task. Now it can be at least more readable. So we have task from the find all repository. We made a new class with task DTO, and then we mapped it to each other, and then inside the DTO, which is the list that we created here. Yeah, good question. Now that you mention it, this one is named tasks DTO, but this one is named task DTO. Okay, yeah, so it's mapped to the correct thing, and then we return that thing here. We have to run this, and there is nothing in the repository, so it should be in the controller. And we should be receiving a list, but we are not. Okay, this is weird. I don't think I have enough power to judge. Why is it going for null? But it's printing the correct information though. it's only the tag, title, and description. So I think the error might be with what is our method here? Task implementation. The issue is with the list. The map is in the DTO, so it should be here. So we'll be receiving a task and giving back a task DTO. We created a task DTO and we said set title to the same title of the given task. Now if you go to the implementation, it says here that the task DTO map to the task, and we're actually getting the task from the repository. Return value of the method is never used. What do you mean never used? I mean, if I put it as void, it will not give me the return type that I'm asking for. But let's see why he's giving me the void recommendation. Okay, if we made it void like he's suggesting. Task DTO. Nope, I don't think it will be working like this. Okay, let's try to rerun here. Okay, everything seems to fine. So again, yeah, it's still null, so it's the same issue. Okay, so we have another issue here.
Do it manually. We'll go down here. We'll go set ID and response. New Pokemon Symphony. New Pokemon down here. Create our very first Pokemon service. But now it comes to the very last part where we take the service and we inject it into our controllers. So we have a straight shot to the database. We can create a Pokemon and we'll test it, and we'll have a straight shot to our actual database. So next thing I'm going to do is I'm going to go into my controllers up here, and it's going to be really easy. Once you get the actual service built, now it just...
I don't think there is an issue with the controller if it's giving us the return type that we are searching for. The controller here, not sure why I had it here final, but we'll check. And then we have here auto-wired with the service implementation, so there's no issue here. This one is a very bad way to actually write it. We should be returning a response entity of type okay, no, my brain just stopped working here. So I think that will be where we stop for today with the Spring Boot project. We finished the DTO, but we have a single issue. Mapping DTO to the actual class. So that will be our challenge for today. Or for tomorrow, I mean. Today we just finished the service implementation and the DTO. Now, now for the actual hustle of this time, is this project. So now we finished this. Let's close this here. So let's close that one and let's close this one. So we are back to here, and I think we stopped at a
friendly and fast. Now
at an error. Let's check. Revise everything we did so far. Okay.
let's talk about what is Angular. Angular is one production. Now we are going to start with creating an Angular application. The way we do that is using the Angular CLI. So
CLI is a powerful tool to generate auto-generated code, boilerplate code specifically, so that you don't have to write it every
to
time.
install the Angular CLI, you already should have Node.js installed. So go to the previous slides where I mentioned what tools we need. And once you have Node,
Speaking about the CLI, what does it stand for? Explain to me more about Angular CLI. Setting up, building, testing, command line interface. Provides a set of commands for common and easier and faster projects. Okay. Project setup, automate build process, development server, testing, code integration. The only useful thing I used it for was creating the components instead of having separate file for each one, HTML and CSS, and I think there is a third one, not sure about it.
Node.js installed, you can run this command to install the latest version of Angular CLI. Once you have that, you can just run ng version and it should show you which version of Angular you're running. For now, I'm going to go to my terminal and just blah blah blah. But what kind of parameters are allowed? So I want to see which one was the inline style, so not inline style, right here. So if I do ng new and I say help, this is going to show me what kind of parameters are allowed.
So it's double. And you actually create the project by ng new and then the name of the project, if I remember. Yeah.
To see which one was the inline styles, not inline styles apparently. So my slides are wrong. So here I can run this without the S in my inline style. So here I'm gonna just remove that. And now I can hit enter. Now it's gonna ask me if I want to use SCSS. Yes, I will, and I'll say no to rendering. And now this will actually create the project for us, and it's also installing the packages for us. Pretty convenient. Now one of the things I want you to see is, in this particular case, it just created an app component TS file. You will see no HTML and no CSS because we opted for inline styles and template. And in the previous case, when we created it, it also created the HTML and CSS or the SCSS file. But we are going to open now this in VS Code. Cool. Now that my app is created, I'm just and the first thing that we are going to discuss.
So you have the component, the app component, which consists of the header and the home, and the header consists of the navbar.
Is Angular components. What are Angular components and why should we care? Angular components basically comprise the whole application. So if you look at any Angular application or any web app,
the definition of Angular component is a bit more subjective depending on the website. What are Angular components? Is a fundamental building block here. It's a block. That part I understand, but consists of template class metadata. Define the piece of the UI and contains the logic. So according to him, though, the app component consists of a home and a header.
Application.
Okay.
They're built on top of different building blocks. For example, you could have a button, you could have a header, you could have a date picker. At any Angular application or any web application, they're built on top of different building blocks. For example, you could have a button, you could have a header, you could have a date picker. All of those things that you see in the UI are actually components. And Angular components are no different. For example, in this app, we are going to look at the app component. We are going to create a header component and we are going to create a home component. And this is sort of the mock-up of how things should look like.
Okay, yeah, I see the difference. I was asking about components, not app component. So what is the app component? The app component is typically the root component that Angular bootstraps when the application is launched. It acts as the entry point to your app and serves as the main container for other components that make up the structure of the application. When you create an Angular project using Angular CLI, it's automatically generated, yes. So can I say that the app component is generally the home page? Yes, you can think of the component, home page or root component of your Angular, but it's important to understand its role a bit more clear in the context. A starting point of your application. When Angular bootstraps your application, it begins by loading the app component, which serves as a root container to the other components. First thing rendered, yes. Home page is the component. In many regular applications will contain the global layout structure, which might include the navbar, a footer, and the primary content area where views are displayed. If you have a home page or a dashboard, it might be part of the content rendered by the app component. So yes. So the more accurate term to call it is that it's the first page that opens up when I click the link of our website. Okay, I see. So I know it's a bit of an early topic to cover, but I want to get more into how does it branches to other pages. So how does Angular branch into other pages? I think by creating a link. If you have the navbar and you create a local link, that's how you do the routing. Navigating between different pages or views in a single page application is typically handled using Angular Router. Allows you to define multiple viewpoints or pages in your app and manage navigation page between them without requiring a full page reload. How does Angular branch? Okay, there's so much loaded. A single app application. What do you mean by single app applications? Is a type of web application or a website that dynamically updates its content within a single web page as the user interacts with it without need to a full page reload. In traditional web applications, when you navigate from one page to another, the browser sends a request to the server to fetch new HTML page. The entire page reloads and the browser URL changes accordingly. In contrast, single pages, no. Use client-side routing to control the navigation. For example, Angular is done using Angular Router. Routing system listen to the URL. Okay, that's a new key concept that I should probably research more, but not at the moment. But it's good to know. SPA, sorry. Okay, I didn't copy it for some reason. Yeah, okay, enable. I didn't know that copy paste didn't exist here. So we understood the difference between the component and the app component.
In our application, the app component is already created when you create an Angular application. All we need to do is create the header component and the home component. But before even going there, I want to show you the app component, how it is right now. Every component in Angular has a TypeScript file, and that has a class. So this class is what tells Angular that this is a component, but not just the class. Above the class, you will always find this component decorator. This decorator basically enhances the information about this class and tells Angular about a lot of things related to this component. For example, what is the selector of this component? That is app root. This is how, when Angular looks at the index.html, it knows that inside the body, this tag which is being used is actually this component.
I think there was something similar in React. So if you want to create a component, you create it and then you call it as a tag inside
And then it goes ahead and
inside the HTML index.
renders welcome to title instead of the app component or inside it, so to say. What I mean is, if I go and inspect it here, you're going to see that in the elements tab, we do have the head, the body, and then inside that we have this app root. Now when Angular looks at this app root, it identifies via this component decorator class that, hey, this app root means this component, which means I should actually render the template.
So technically we're creating our custom HTML tags that can run that can render TypeScript with the CSS styling, and then we put it at the end with the HTML file,
which is right here, and thus it goes inside and renders h1 and router, as you can see. If I change anything inside here, it is going to render it inside the app root component, easy peasy. Now one of the things that I would highly encourage you to do is to use the Angular DevTools extension, and this is how the extension looks like. You can just search in Elements tab, you will. So here you see we have the app root component, and inside that we are also using a router outlet component, but we're gonna talk about that later. In the app root, you see this property called app title, or just the title, which says first ng app. If I change this to essence app, for example, hit enter, you can see that this renders right here. So that's one thing about the component part, that is the selector, the app root. What else do we have in our component? We have standalone true. You can ignore this for now because it doesn't matter at the moment. This is also going to be removed going forward. What I want you to focus on is the template right here. The template here essentially is what gets rendered in the view. For example, I could go here, and here I can press or type a p tag, for example, and here I could say something.
This is the part that we changed with the component.html part, yes.
Like hello world, and if I save this, go to my browser, I don't even have to reload my.
So wait, because I didn't pay attention to that part last time. So it's called header.component, and then we have app.component, and then we have home.component. Okay.
App Angular dev server automatically reloads it, and now you see we also have this p tag right here in our elements, which means that whatever I render here or type here, it's going to be rendered in my application. Now apart from this template, you also see this styles right here, but what you can do here is that you can
yes, add the CSS style as an inline text, or you can just add the app.css URL.
add backticks here, and actually write the styles here. For example, here I could say something like p tag is gonna have a background color of red, for example. If I do this and save this, you can see that automatically my p tag now has the background color applied. One of the things that I really want to enforce here is, if you look at the styles here, you're gonna see something interesting. You not only see the p, but you also see this bracket and something interesting going on here as well. And when you see the code, it's just p here. So what's really happening here? Angular makes sure that the styles you write within a component stays within the component. For example, if my global HTML after my app component had a p tag, and this was something like this is outside of app component, if I just do this p tag will not have the styles applied here, which is one of the most important things for a web developer, to not leak styles. If I go to my app, you can see that this p is not affected, and the way Angular deals about this is that whenever you have a component and a style within the component, Angular first adds a particular attribute to that particular component, and then all the styles also have this attribute as well. For example, if I click P, you will find this exactly has the same attribute style. This is how it is essentially containing, or not exactly the same one, the ng content one. So this is how it is actually.
My brain is getting fried really slowly after the DTO content that we just did.
Containing the the styles within the component, not leaking outside. So I can quickly just say p tag or h1 tag, but I won't have to care about if the styles are going to be leaked out. Now we're going to continue with our logic of header and home component. What I want to do now is to create both of these components so I can render it just like this. So for this, you can just say ng generate component, like this whole term within the full form, or you can just say nggc and you can give the name of the component. When you do this, it creates it inside the source app folder. Let me show you. If I go to my terminal and open a new one inside the
Create it inside the source app folder.
App folder, let me show you. If I go to my terminal and open a new one, I'm gonna let my server keep running, and then I'll open a new terminal. And in here, I want to run the command, and I want to run this with dry run so I can show you what happens when I run this. You can see that this generates a component inside the source app, and then it creates a folder for the header.
That's not good because it's creating it at the same place as the app component, which is not good. You should create separate folders for each of the components.
And then creates the files inside those. Now I don't really want that. I want the header component to be inside a components folder. And the way you do that is that you can say ngg component or ng generate component, and then you give the path components / header. So then it generates inside the source app components and then the header folder and then the header component. So this is what I'm going to do now. I'm going to copy this now, and then I'm going to run this with the dry run flag. And here you can,
so you create a components folder and then you add the header and then you add the content. I don't think we added the content yet, but we should also have a footer if I remember correctly. So this is the components and the home. I mean, everything here will be component space, so there is no need to actually create a component folder. So even technically the home is a component, he didn't put it in the component. Okay.
You can see now it generates inside source app components.
Because
Then
the header will probably exist of both the navbar and what the other thing was, the logo, so it will probably be consistent across the pages, but the home page will not be. It will be a one-time thing.
And then the header files. One of the things that you'll notice is that now none of my files have the SCSS file and also the HTML file. I don't really want that, so I'm going to change something in my Angular JSON. In here you can see that we have this projects first ng template, and inside schematics you can see in the Angular component I have inline template true, inline style true. I'm going to actually remove these so we have separate files going forward. So I'm going to save this now, and I'm going to run the command again. Now you can see that it generates the HTML file as well, and it also generates the SCSS file. Now I'm going to run this without the dry run, and there we go. Now we have our component created. If I scroll up, look at here, we have the components folder, and inside we have the HTML and CSS files containing those things. And in the TypeScript file, now you're gonna see something different. Here we have the selector called app header, but now instead of the template, unlike here we had template, now here we have template URL, and it points to where is the HTML file for this header component compared to the TypeScript file. And it's right here, so this is pointing to the right file. Similarly, it's pointing for the SCSS file. And now that we have the header component, let's also generate the component for home as well. Since home is going to be a page, I'm not gonna actually create a component in the components folder. I'm going to create this out.
Okay, yeah, that was I was going to say. It's technically a page, but also a component. Okay, so the way that I see the people use component here is two things. Its general term is it's a building block. So in that case, yes, it is a building block, but a very big one compared to something like the header, which is a small one. So you can say that there is two types of components. You have the page itself, and then you have the repetitive components, something like the navbar or buttons and stuff like that.
Side. So let's do it like this. I'm gonna just say nggc and home, so I can create it outside of the components folder. And now we have a home component right here as well. Now what I want to do is to be able to render both the header and the component and the home component right here inside my app component. So ideally my app root should show app header and app home. For this I'm going to do two things. One, in my app component
you have to add the home. So there's two ways. You can either add the tag itself to the index HTML, which I'm not sure how you even create the tag for it, And the second one is to add it to the app component. Actually, no, you cannot add it to the HTML, because to the HTML we only add the app component itself. So if you want to add the home page, you add it to the app component.
I have to
So you put it inside the template.
render both of them. I have to first import these components. So here
Yeah, inside the imports first. That's one thing I learned from the ng format.
I'm gonna go and add home component just like this, and I'm gonna hit enter, and it's automatically going to import this. And then I'm also gonna say header component just like this. Now that I've imported those,
Okay, yeah, definitely hearing it yesterday wasn't enough to get it all from the first time, so good thing that I repeated everything I did yesterday, because I'm basically restudying the same video that I just did yesterday also. So the app component is where all the action will go to, and no, you cannot go to the index HTML directly. You have to go through the app component first.
I can remove all of these from here, and then I
In this case also we can add a footer.
can say something like app, and you can see Angular language server, that is the extension for VS Code, is already helping me. So I can say app header just like this.
So the way that you create the tag is by having it inside the imports. So how about the index HTML and the component itself? So that's the app component, and then he added inside the template the navbar because of home. But how about the index HTML? It has the app root, and that's the selector for it. So by changing this you can change the name of the tag. How about let's go to the header. Header, and then you have the TS. The header is called the app header. So if you want to call it inside the component here, you should call it app header, yes. So when you create a component with the 4 files here, and you want to use it as a tag inside another one, you first import it, which is header component or home component. In the case of header component, let's go back. App header. So you import the name of the class, but the tag is the selector. Okay.
This, and I can say app home just like this. Now let's save this, and if I go here, you can see it says header works, home works, and as I said, now the app root has the app header and then the app home. Easy peasy. I'm gonna also go and remove this paragraph from the index HTML. We don't really need that, and this looks super nice now. Now what I want to do is to style this a bit better. So first I'm gonna go to my style CSS and add some styles. I'm gonna
And that's the style for the index page, so it's a global thing.
say that we have the HTML, we have the body right here, and then we are going to simply say margin 0, padding 0. We are also going to say asterisk outline none, and now we can quickly go ahead and style the header and the home. So first I'm gonna go inside the header component, and here we have a header works. So here we are going to first create a nav, or instead of the nav itself, we are also going to create a header component as well. Now we're gonna put the nav inside this, so let's do that. And
I think it's better for research to put the header in the navbar, because that's how Google identifies the navbar, by seeing the header tag. It was something like that, but I'll probably need to check it also later. But for now, I'll be
inside
just
the
watching.
nav, we are going to say my first Angular app. So here now you can see my first Angular app. Now we are going to style this a bit. So we are going to quickly go to SCSS, and here we are going to say this header is going to be a display flex. We're going to have padding inline set to 16 pixels.
Yeah, another thing. Okay, that's frontend. But creating different navbars, because styling a navbar is a repetitive task that I should probably get to use to first.
We are also going to have padding block set to 8 pixels. We are also going to have the background color set to 333, and the color is going to be white. We're also going to have items center or align items center, and justify content set to between, space between.
I know the tags, but I never use them. CSS is weird. I know a lot of stuff about it, but I haven't got any practical experience with it because I haven't designed site. Because web design and web development can go like really hand in hand, so I need to find a design and try to implement it as
Now,
much as I can.
one of the things that I did wrong was the header here. So this should not be a class but rather an element. So let's save this. And now you can see that I did wrong was the header here. So this should not be a class but rather an element. So let's save this.
Also, CSS class selector versus element. I guess the reason here is very simple, is because the CSS style doesn't leak here because of the way that Angular is designed. So you don't have to specify the class of the header, just the header itself.
And now you can see that we have a really...
And if I have another header class outside of this header component, it's still not affected.
Nice header that shows right here. Now we're going to make sure that the padding that we have in the header is same as what we have here. So what I'm going to do is I'm going to actually go to my app component here, and instead of the app home, I'm going to put that inside the main tag, something like this, and I'm going to put the app home right here. And what I'm going to do is to style the main tag here. So I'm going to quickly go here and say, instead of this, I can say main, and instead of this style, I'm going to say simply padding inline, and this is going to be 16 pixels.
The thing is, you know CSS, but you don't know when to use certain stuff. Like the thing he's saying is, I understand that, but they never occur to my brain for some reason. How to use CSS to design for website design. And we will check that one later also, because I don't plan on doing a lot of Angular today since I have some stuff to do after the stream, and I'm also broke after the DTO battle. It's still stuck in my head for some reason. CSS design, because if there's one thing that's stopping me from doing like proper full stack development, is the front end part, and it's the CSS, not even the JavaScript. Yeah, I don't like, and I don't think anyone likes to deal with CSS.
And padding, or actually I want the padding to all of the sides be 16 pixels. Now when we go here, you can see that the home is aligned with the header. Super cool. And now that we have this,
now that I remember,
working,
there was a video related to designing with CSS and how the design, how to use pixel, which pixel to pick, and all the stuff that I forgot which video it was. Nope, we'll probably have to spend some time in CSS soon. But not in the way that you think. Not to actually learn tags, but actually to do actual design. Okay, there is the nav bar here.
Hey, I'm Hunter.
And yeah, how do you study even CSS? How to study, or how to be good at CSS? I guess just using CSS more, but I do understand the basic tag. The principle, the flex one, I do get it, but I still have to search it a bit more. Responsive design, work with CSS processors, SAS, and all that stuff. Oh, okay, that's not helping.
Want to go forward. Now we are going to talk about Angular data binding.
So now we know how to push the design part.
What is
where? Okay, there is a center part that I need to go back to. Around 23. Yeah.
Super cool. And now that we have
I'll just glimpse over it, but I will not actually do anything. I will do the thing again tomorrow.
This essentially working, I want to go forward.
Because I want to separate understanding from actual coding, because that part is the part that where you use CSS. So
we're going to talk about Angular data binding. What is Angular data binding? Why is it a really important topic? Angular data binding is the way you bind the data from your TypeScript class of Angular to the template, which is the HTML. How do you make them communicate with each other, and
then how do you make TypeScript communicate with the backend? Do you use just the normal fetch way, or there is a way in Angular to do that?
Render data dynamically if the data changes. So we're going to look at some examples. One with the modern Angular signals, and second, which is not so modern, but you can say, for example, Angular 16 and below, but it still works till today. So with the signals, which is a new thing in Angular, what you do is you can, in your TypeScript class, create a signal. You can create a signal of type string.
Okay, what do we have here? Import a component called signal, sure. And then we have, here's the template, here's my value, and then the brackets, and then you put my var.
A number, an object, doesn't really matter. It has to be a signal. And once you have the signal, you essentially can render this in your template using these curly braces. So you need to have
Do we? I think we just write it
in your
normally.
template these curly braces, and inside you can use any of the variables from your TypeScript class. So let's try these now. So I'm gonna go to my header, and inside my header, you're already seeing that in the HTML we say my first Angular app. What if we did not hard code this in the HTML and
instead
add it
title
inside our
except.
TypeScript? So here we can say we can create a title property, and we are going to make it a signal. So as soon as you type signal, you can click it. You can see it imports from the signal right here from Angular core, and here I can say my first Angular app. And once I have this title here, now I can go to my HTML, and here I can get rid of all of this, and I can use the double curly brackets, and now I can say title. Since title is a signal, Angular's language service will already tell you that this is a function and it should be called just like this. This is a recent improvement and I love it. So I need to call it just like this.
Wait, was it a function? I haven't
put this
noticed.
title here.
Title is a signal, and a signal is probably a function, but title in itself, I don't think so.
Now I can go and already tell you that this is a function and it should.
Okay, so that's the difference between rendering it to text, like the one that we use. You just write the variable name itself, no issues. Or with function.
Like
with
this.
function, probably you need to use signal.
This is a recent improvement and I love it. So I need to call it just like this. And this is exactly how you retrieve a value from a signal. Now if I go to my application, you can see it says my first Angular app. Now this is not coming directly from the HTML. It's coming from our TypeScript class using the signal and being rendered here. If I go to my Angular extension here and click app root, and inside app header, you can see that the title here is essentially a signal that has a value my first Angular app. And I can change this to, for example, SN, and I hit enter, and you can see that this changes here as well. So this is actually coming from the property within our app header component. This is not hard coded. Now the other way we create data binding within our Angular application is using without signals. And the only change in that is that you don't really use a signal property, and you don't really call the function invocation here. If you compare this with this one, here we needed to use the small brackets, but here we don't really need to use the small brackets at all. So if I wanted to change that, and if I wanted to remove the signal,
Yeah, that's the one that I know, but what's the difference between both of them if they give the
From
same
here.
result?
then my HTML template will be really angry with me, and I need to remove this as well. And if I save this now and go to my application, you can see it still works. You can still see that the header has a property called title. Now this is not a signal, as you can see, but if I change this to anything as well, you can see that the changes reflect here. Now the question would be, what should you use? Should you use signals, or should you use non-signals? I would highly encourage that you start using signals from today, because this is going to be the de facto way of using data binding in the future. So don't use the traditional way unless you really have to, or if you're working with Angular 16 or below, so to say, where signals are not really mature. So I would highly encourage to use signals whenever possible. Now the next thing we
Okay,
want to
sure.
do is to
Why
implement
not?
more components inside the home component.
Nested components, sure, why not?
So So we are going to have a counter component, and we are also going to have a greeter component. We are going to start with greeter because I want to show you another thing about data binding. So we are going to start with greeter.
So the header component, that's it. Okay.
Because I want to show you another thing about data binding. So we're going to create the greeting component just like this. So I'm going to copy this. I'm going to go to my code, go to my terminal, and here we are going to just run nggc components/greeting. This is going to create another folder inside the components, and now you can see components has the greeting folder as well, and now I can use that. Now what inside the component nggc.
Okay, I'll stop at that writing actually, because I need to actually write these stuff before I forgot them. But anyway, that will be it actually for the Angular. I don't want to have more of it because my head is already full of it. The thing about Angular is, which class did he just create right now? He created, inside the components, he created a greeting. And inside the home component, he has two components. That's too much components for me. I think that will be enough for Angular also today. So I'll be saying goodbye to YouTube, and we will be moving on to PoE. So for the only one watching, I'll be on Twitch, no, not on YouTube. So I'll have to end the stream right now.